So we're about to explain one of the most important concepts in finance, which is the time value of money. Just to set things up, you are constantly in the trenches, right, doing business, and you constantly have to make decisions as to how you allocate your resources. So you need to determine whether you're willing to invest a certain amount of funds in order to acquire an asset, or invest in the company, and so on. The investment is known for certain, right? You know that you need to spend X amount of dollars to acquire a certain asset. The issue is that the benefits of that investment are unknown in the sense that they are future or expected values. You can forecast them, you can try to estimate what they would look like, but in the end, there's two things. There's a certain level of uncertainty, and second of all, those returns, those compensations, those benefits are located at future points in time. So how do you deal with making a decision today based on benefits that you will receive in the future? This is what the time value of money does for us. So let's just start by basically proposing that you always try, at least initially, to visualize everything from a timeline perspective. Okay, that's a way in which you can see the cash flows. So typically, if you receive a certain type of cash flows, right, cash flows 1, 2, and 3, and so on, okay, they're located in a timeline perspective. So cash flow number 1 is going to be received in period number 1. And if you place a certain amount of money or fund above the number 1, what that really means is that cash flow is being either paid or received at the end of year 1. Why? Because the beginning of year 1 begins at time 0. Okay, I hope this makes sense. So for example, if you see these $100 located over the second period, then what that means is that you're going to either receive or pay $100 at the end of year 2. Okay. This implies that you will pay or receive $100 at the end of year 1. But you can also assume that it's the beginning of year 2. Okay, so you can look at it different ways, right? But I would argue that in order to avoid confusion, if you're standing over the 1, then this is at the end of year 1, right? This is called an ordinary annuity. Ordinary annuity occurs when you have equal payments, the equal amounts, with the same periodicity, right? So these amounts occur every year or every period, right? These periods could be 1, 2, 3, could be years or months for that matter, right? So an ordinary annuity is an annuity these are payments that of equal amounts, the same periodicity, and they occur at the end of each period. Okay, so the first $100 will be paid at the end of year 1, the second at the end of year 2, and the third at the end of year 3. Okay, if the payments occur not at the end of each period, but at the beginning, so like this is called an annuity due. Okay, the annuity does not imply that it has to be annual. It just implies that you have to have the same periodicity. Okay, so this is an annuity of $100 that occurs at the beginning of each period. The previous one was one that occurred at the end of each period. Okay, now let's talk about time value of money. Is $1 today worth more than the same dollar, let's say a year from now? In other words, would you prefer to receive $1 today rather than receive it a year from now? The answer is yes. And the reason for that is there's at least two different reasons, right? First of all, if you receive $1 today, you can earn interest on that dollar. So by the time 1 year elapses, you will have more than $1 in your account. So therefore, you prefer to get it as soon as possible, right? That also refers to having funds or money having an opportunity cost. There's an opportunity cost of capital, meaning that if anything that you do not receive today, then it will not be able to earn a certain rate of return that you could otherwise achieve. So for that reason, you prefer amounts today. So the value of $1 today is higher than the value of $1 a year from now. It's worth to you more today than in the future. Okay, that's the first thing. The other argument is that because of inflation, then you also will prefer to receive $1 today because $1 today will allow you to buy more things than $1 a year from now, because after a year, there will be a loss of purchasing power. Okay, of course, this is true for economies that have inflationary conditions. All right, so for that reason, let's talk about how we can estimate, how can we assign values, right? And in fact, different values to amounts located at different points in time. To do that, let's just start in a very simple manner. Okay, let's first find what we call the future value of an investment. And the future value just indicates the value that a current investment will achieve after having earned a certain amount of interest over a specific amount of time. All right, so future value is intuitive enough. How much will I have at the end of X number of years if I'm earning a certain interest every year during that time? Okay, so let me give you an example just to set things in a more clear path. Okay, a simple question can be, how much would you have after 2 years if an investment is made of $100 and you know that you're going to earn 10% every year? Okay, so there's a very important sub-concept that we apply in finance that's called compound interest, right? And what compound interest basically means is that we assume that interest payments are always reinvested. So if you put this money into an account and you earn 10%, the first funds that you receive in the form of interest will be left in the account and reinvested. Okay. Every time we apply this concept of time value of money and that for valuation, we always assume reinvestment. If you don't reinvest, there are adjustments you can make, but typically the assumption is of reinvestment. So what will that do to your investment? At the end of year one, how much will you have? Well, you'll have first of all, you started with $100. And then that grew because you earn interest of 10%, right? So that grew by 10% during the first year. So how much will you have at the end of the first year? You will have 100 multiplied times 1 plus the growth rate of your money in this case, right? Which will be 10%. And that gives you 110. The 10% is expressed in decimal form in this way, right? Because what we were doing is just taking 10% per 100, right? Which will give you 0.1. Anyways, at the end of the first year, you'll have $110. Then you reinvest those funds onto the second year. So in the second year, you start with 110 now, and you again, invest those funds, leave them there, earning 10% again, one more year, and so you get $121 at the end of the 2 years. If you had not assumed reinvestment, what would have occurred? Well, you would have earned 110, right? Then you would have removed the $10, right? This part you would have removed from the account, and you're left with $100 again, which in turn would earn 10% during the second year. So to make a long story short, if you had not assumed reinvestment, how much money would you have earned overall? You would earn the $100 that you started with plus $10 in the first year and $10 in the second year. You would have earned a total, your future value would have been $120. You have here $121 because of the reinvestment. This looks very small and not unimportant, right? Very innocent, but the reinvestment assumption is very strong. We'll see later how reinvestment and is actually the main benefit we get when we save for our retirement. When we save for our retirement, the benefits are not necessarily how much money we are able to save, but the returns that we earn over interest as we leave the money there being invested for years. Now, let's look at the 121 for a second. That 121, right, is the result of multiplying 110 times 1 plus 0.10. But the 110 comes from the first year. So I can rewrite the 110 as 100, right, times 1 plus 0.1. And that is multiplied times 1 plus 0.1 again to get the 121, right? No mystery there, correct? But notice that these two are the same. So I could really rewrite everything as 100 times 1 plus 0.1 twice, right? How do we do that? You square it. That gave you 121. And here we start observing that there's a recipe in place, right? If I know that I'm investing a certain amount today, earning a certain interest, and leaving it there for a certain number of periods, then I can use this formula except for any situation, except that if I leave it for longer, then this 2 will become 3, 4, or 5. And if I'm earning more or less interest, then this will have to be modified. So I have a recipe now to find the future value. The future value of an investment is just simply the investment itself multiplied times 1 plus the return I earn, the compensation that I receive, the interest that I receive every period, every year in this case, right, raised to the number of periods. So the future value at the end of year 2 will be my initial investment, the $100, multiplied times 1 plus my interest rate, which in my example was 10%, raised to the, how many periods was that? 2 years. And that gives me $121. Okay, so this is the first part of the conversation. We have just found a way of finding the future value of an investment today. The investment today was 100, and that became 121 thanks to the fact that it earned 10% for 2 periods and all interests were reinvested.